One type of regulation is what's called the New Source Performance Standards, or the NSPS. These are national rules for emissions. They apply to things like power plants, cement plants, incinerators, chemical plants, oil refineries, etc. On the next slide, we're going to look at an example of new source performance standards just for a subset of these for power plants. This is table 2-3 in the textbook by Wark, Warner, and Davis, which is air pollution, its origin, and control. And this applies for sources that are produce greater than 73 megawatts of power, that are built after September 1978. So if you're older than that, you're grandfathered in. And they are written for SO2, which comes from sulfur in the coal, nitrogen oxides, NOx, which forms during high temperature combustion, and also particulate matter, which comes from ash in the coal, things that don't burn in the coal, and also from formation of particles during the combustion process itself. So this is entitled New Source Performance Standards for Fossil Fuel Electricity Utility Steam Generating Units. And you can see there's categories A, B, and C. So there's an SO2 standard, and this is for a coal-fired unit. And in words, it says the standard requires at least a 90% reduction of potential SO2 emissions and limits the SO2 emission rate to 1.2 pounds per million BTU input, or requires a 70% reduction and limits the emission rate to 0.6 pounds per million BTU, blah, blah, blah. The little table right below that showing the UER is actually an easier way to figure this out. The UER refers to the uncontrolled emission rate. So how much SO2 is coming out if you burn the coal and you don't have any type of emissions control equipment. And you can see that if your uncontrolled emission rate is less than 2 pounds of SO2 per million BTU, the million BTU refers to the amount of energy or heat input from in the fuel, the coal that you're burning, then your required efficiency on controls is 70%. You have to remove at least 70% of the SO2. And you can see that if your UER uncontrolled emission rate falls between 2 and 6 pounds of SO2 per million BTU, then you have to get your emissions down to 0.6 pounds of SO2 per million BTU. So from whatever it is, like maybe it's 3 pounds of SO2, you've got to get it down to 0.6. And then you can see for higher amounts of SO2 emissions, the uncontrolled emission rate, there's these other stipulations. Let's talk a little bit more about this. What's happening with the power plant? Let's say that we have a power plant that has a thermal efficiency of 35%, which is pretty typical. That means if we burn a certain amount of coal, let's say we burn 1 million BTUs worth of coal. I know we typically think about coal in terms of mass, pounds or kilograms or tons, but the way these standards are written, they think about the amount of energy in that coal that you're using. So we burn a certain amount of coal, that's equivalent to 1 million BTUs worth. The thermal efficiency is 35%, so we get 350,000 BTUs worth of electricity. The other 650,000 of BTUs is lost as heat. And while we burn the coal, we end up generating SO2, and This is the uncontrolled emissions. And let's say that we generated 1 pound. So our UER, uncontrolled emission rate, is 1 pound of SO2 per million BTU of heat input. Now, we go to our new source performance standards, we look this up, we find that if we have a UER of 1 pound per million BTU, we need to reduce our emissions by 70%. And so we have some kind of control device that removes 70% of the SO2, resulting in emissions of 0.3 pounds. And the other 0.7 pounds is removed. Now, if we go back and look at the new source performance standards, we'll see that in sections B and C here, they also have a standard for particles. Emissions are limited to 0.03 pounds per million BTU of heat input. And also it limits opacity to 20% for a 6-minute average. I'll show you what that means on the next slide. And there's also a NOx standard for nitrogen oxides. Depending on the type of fuel you're using, whether it's gaseous, liquid, or coal, it's less than 1 pound of NOx per million BTUs. Now, for particles, opacity refers to how well you can see through the plume, like how hazy it is. And you can see that in this illustration, it shows some example opacities. There's like 20%, which is still legal, so you can see a little bit through it. 40% is bad. 80% is crazy. If you go look at Cookout in Blacksburg, you will often see a whitish plume with high opacity, which is probably violating some type of emission standard if that applies to it.